So we're going to come full circle with where we started with this chapter and talking about passive and active immunity. So passive immunity, remember, is when an individual is given antibodies. Active immunity is when the person has been infected by a pathogen and then they continue to recognize that pathogen and continue to make those B and T cells. We talked about that primary versus secondary response. We know that we can induce that primary response by way of vaccines and through that artificial recognition. So with this section, we're going to talk about immunization and vaccinations. If you remember with that primary response, that's the first time that our body encounters that antigen. So if we're artificially inducing that through a vaccine, our body is going to recognize it. Those B lymphocytes are going to start to clone themselves. Plasma cells are going to start to produce antibodies. And then we're going to have those memory B cells hang around. Those memory B cells are going to help us to recognize it the second time that we see it. And remember, that was our secondary response. So this is going to be much quicker and faster. Those antibodies also, through this response, start doing a better job. And so they get better and better at fighting these antigens and pathogens. So if we introduce that antigen by artificial means through a vaccination, we first have our primary response, and then that secondary response, if we were to actually see that disease in real time, our body is going to be able to recognize it and is going to be better able to handle it and hopefully knock it back before we get sick or land in the hospital. So immunization, also what we call vaccination. Vaccines can contain either live or attenuated organisms. So one term that I want you to be familiar with is attenuated. So anytime that you see the term attenuated, that means that it has been weakened in some way. Now, it's important not to administer a vaccine that is going to make somebody ill. So oftentimes, those organisms, especially if they're live organisms, have been genetically engineered. They've been weakened in some way, attenuated, so that they cause an immune reaction to start making those antibodies, but they're not making the host sick. Now, how long can vaccines last? It really depends on the vaccine. We know that because of that antigenic variation with the flu virus, we have to get a flu vaccine every year. Some live vaccines tend to last longer. So there are also some vaccinations that will have very good long-term immunity. So MMR, we'll talk a little bit about that, mumps, measles, and rubella. That actually has very good effectiveness. And then there's also the varicella as well, vaccine for chickenpox. So how long vaccines last really depend on the agent, also depend on our immune system. So how serious does our immune system take it? It also depends on any mutations that happen with those viruses. So for example, the flu virus, COVID, we know that COVID has mutated, and we've had several variations of vaccinations. Sometimes we might require booster shots. For example, I recently got my Tdap booster, and that is for tetanus, diphtheria, and pertussis. They recommend that adults get that every 10 years. And so oftentimes it's just a little reminder to our immune system to say, hey, remember this, you want to make sure that you're taking this seriously. The one thing that does matter is how we're actually administering these immunizations. So oftentimes they will say that intramuscular may not last as long as nasal or oral. immunization vaccine. And the reason for that is that if it takes the usual entry point that the pathogen would, our body is going to be better able to recognize it. So if you remember, we went through the pathway and the antibodies that that pathogen would meet. It's the same type of thing for the vaccine. And so that's why the route does matter. And they have actually found that in cases where it's taking that normal route that the pathogen would, that our immune system is better able to recognize it. So we're going to talk about some different vaccinations, some that we have probably all had and that we are familiar with. And so first up is the MMR vaccine. So there's the mumps, measles, and rubella. So mumps is a viral infection that affects salivary glands, and you can get fever, headache, and swollen glands. Measles, also called rubeola, you can get a fever and rash. Measles tends to be worse than rubella, which is the German measles, which also causes a rash as well. So we have all gotten the MMR vaccine as babies, and it is very effective. I happen to be born at a time where they were either giving it to us too young, or it wasn't really an effective formulation. And that left members of the population in my age group kind of vulnerable. And when I was in college, coming back from spring break one year, we had a student that they thought had the measles. Our campus wanted to take it seriously, so we all had to get the booster. And so we had to stand in line at the student union, and we had to get our MMR vaccine. We got a little vaccination card. We had to present that to get into classes. Once you got into class, they would close the doors. The doors would lock so that nobody could get in unchecked. The ridiculous thing to me, though, is that, they wouldn't let us into class without our green vaccination card. But yeah, we were all in the dorm rooms. Nobody was checking us in the dorms. I was, even then, I thought, okay, this just doesn't really make sense. I really think about that, and I'm glad that that actually happened. I did know this student, and she didn't actually have the measles, but I'm glad that we did get the booster, because I believe that I was in that generation where it really wasn't working. And the reason that I know that is that when I was 6, I actually had the mumps, and my face was like blown up like a chipmunk. Also happened during a flood that my family was in. Not exactly a good time. But I still am glad that at least we ended up with that MMR booster. Diphtheria. So this is another disease that we get vaccinated for, and this is caused by bacteria, a Corynebacteria. Because of widespread vaccination programs, there are limited cases, which is good. Again, I mentioned when I got the Tdap booster, that helps to protect me against diphtheria. What can happen with this disease is that it can form these pseudomembranes that can block airways, and that's not a good thing because people can suffocate, so that's obviously not good. Whooping cough, pertussis. Again, this was the other agent that was in my Tdap booster that I got. We often know pertussis by the name of whooping cough. This is caused by Bordetella pertussis. We used to hear about this a lot in young children, but we're finding that adults are getting it as well. Because people are choosing not to vaccinate, we're actually seeing more cases of pertussis and whooping cough. I'm not going to quiz you on the pathology and treatments. I had a friend, and she and her son were both vaccinated against pertussis, and they ended up getting it. And she said the coughing fits were so intense that she said she would hold on to a chair because she was so afraid that she was going to fly away from those coughing fits. Every once in a while, you do hear about outbreaks. I remember a couple of years ago, I read about a hockey team that had been taken down with whooping cough. So this is one of those things we never used to hear about, but because people are choosing not to vaccinate for whatever reason, we do see some recurrence. So speaking of that, why might people choose not to vaccinate? Sometimes people are going to be at more risk. And this is really what you have to do, is that you have to do sort of a cost benefit analysis. We know that there are going to be secondary side effects. Yes, they can be painful. There could be redness. I know every time my daughter gets a vaccination, her arm gets super, super red. She was always very reactive to vaccines. We know that some people are allergic to some of the excipients in the vaccinations, and so they cannot have certain vaccinations. And we also know that certain individuals, if they're immunocompromised, should not have live virus vaccines. So, for example, pregnant women that are immunocompromised, or people that have maybe cancers, or if they're taking immunosuppressant drugs, that live virus could actually make them sick. So when my children were little, I would take them to get their flu vaccinations. We go to the pediatrician. And of course, my kids, like any other kids, did not like getting shots. And so the nurse would always say, well, perhaps you could get the nasal spray of the live vaccine. Of course, my kids were all over that. They're like, yes, we want the nasal vaccine. And I'm like, who are you kidding? You're not going to like that any better either. But because my husband has Crohn's and he is immunocompromised because of his immunosuppressants, they were not able to get it. So when they asked, is there anybody in your household that is immunocompromised? And I said, yes, my husband is. They said, well, then they cannot get the live vaccine. So there are some reasons why people choose not to vaccinate. I know that there is a lot of misinformation out there, and I always ask students, when you are looking at information, and I know social media is a big place to find a lot of information, even on the internet, do your research, put on your science hat, look at the studies. Is this a valid study? Is this a primary resource? Why is this group conducting the study? What is the impetus? What's the motivation behind it? So when you see different forms of information out there and it comes to choosing your healthcare and what you are doing for your own health and your family, I'm going to ask that you put your science hat on, think like a scientist, and make an informed decision. So what makes an effective vaccine? Well, first off, it has to protect against the disease. That's going to be first and foremost. We want it to do its job. We also want it to be safe. We don't want it causing more harm than the disease, and we don't really want a lot of side effects. We certainly don't want a lot of people in the population to be allergic to it. The other thing is that ideally we'd like it to have long-term protection. We want to make sure that it's doing its job, that it is producing those neutralizing antibodies, so that our immune system is able to recognize it and do its job. The other thing is that we want it to be stable and we want it to be cost effective. If it's so expensive, people are not going to be able to get it. It also should be stable. This was really a concern with the COVID vaccines and the mRNA vaccines because they needed to be kept at a cooler temperature. And they were concerned about certain geographic areas where it was going to be difficult to do that. And there were a lot of efforts put into place to make sure that it would actually be kept at the proper temperature and given to people in those certain geographic areas. So what are the different types of vaccines? So because of the COVID mRNA vaccine, I actually did have to update the slide, but there's whole cell killed, which tends to be less effective than live vaccines. Again, if it's killed, it's not going to cause harm. It still is going to have all of those antigenic properties that the immune system is going to recognize. But remember that with that danger signal, if our immune system takes it really seriously, our immune system is going to remember it. We also talked about live attenuated, live so that it has all of those components, but it's weakened in some way so that it doesn't make us sick. A lot of times vaccines will actually use portions of microbes. So a subunit, so part of an antigen, part of a protein. Many times the vaccines on the market today are recombinant. So they're actually designed in a lab, inserting genes for antigens in non-virulent organisms so that they can actually make those antigens. And even though the research has been around for many, many years on mRNA vaccines, our COVID vaccines, some of them now are mRNA vaccines. And these were actually the first mRNA vaccines to actually hit the population, even though there has been many, many years of research. And what these mRNA vaccines do is that they basically have the instructions. So remember our protein synthesis, the copy of that gene is kept in messenger RNA. That copy is administered to us. Our body then can produce that protein. Our immune system can see it as being foreign and then recognize it and mount a response. I do have in our homework assignment a paper that does talk about traditional and mRNA vaccines for a little extra research. So the vaccinations we've been talking about were active immunity. So our immune system being able to recognize those antigens and mounting a response. There's also vaccines that can be involved with passive immunity. This is when individuals are given antibodies to fight a disease. But remember, once those antibodies are used up, then the person is on their own, and that's when their active immunity is going to have to take over. Now, most passive immunity that we talk about is going to be artificial. The only type of natural passive immunity that there is going from mother to baby. So newborns are immune to some diseases because the mother's antibodies have actually crossed the placenta. Some of them can also be found in colostrum in breast milk. Mostly with passive immunity, we talk about artificial immunity. So some individuals could actually be given antibodies if they were exposed to a disease. And oftentimes we see this with gamma globulin. So if let's say that somebody in healthcare has a needle stick, potentially they could be exposed to hepatitis. They would be given shots of gamma globulin. And those antibodies would basically go out, tie up those antigens, neutralize them before they caused harm to that individual. Another case of these antibodies being administered, we'll talk a little bit about in the next chapter with Rh negative mothers and potentially being pregnant with an Rh positive baby. So we will get into that a little bit more when we talk about different reactions that can happen, like with different allergies, the cytotoxic response. Hyperimmune sera, this is when people are recovering from a disease and the antibodies that they have in their system are basically selected and collected. Then what they can do is they can take those antibodies in that hyperimmune sera, and then they can actually give it to people to help them recover from a disease. This is actually what they were doing with especially healthcare professionals that had been exposed to Ebola. They were collecting that immune sera, and then people that were fighting Ebola, they were actually able to administer it and they were able to recover. And so taking something that was very deadly and being able to allow the individual to recover. They can also use certain antibodies specific for different toxins. So think about things like antivenoms like snake and spider bites. Of course, anytime that you're administering anything, whether it's antibodies or whether it is a vaccination, one thing that we're always concerned about are the different side effects, people possibly having allergic reactions, reactions at the injection site, and other issues happening within that person. The last thing that I want to talk about is herd immunity. And this is a common term that we've probably all heard of. I tend to like community immunity a little better. I think it defines it a little better. And so what herd immunity or community immunity is when a large portion of the population has become immune to an infection, usually through big vaccination programs. And what this does is it helps to protect those more vulnerable individuals in the population that can't vaccinate. So individuals that are immunocompromised, individuals with cancer that aren't able to get vaccinations or are immunocompromised and could potentially get those diseases. And so because of large-scale immunization programs, this is what has made community immunity possible. And this is something that actually protects all of us, not only the immunocompromised, but all of us. Nobody wants to get sick. But if we have a large portion of the population that is immune, then there's less chances for it to actually spread and that we're going to come in contact with. Now, I did post a little video. It's only like a 2-3 minute video, but I think it does a really good job of actually describing and visualizing this community immunity.